Have you ever wondered what it would be like to have a duplicate of yourself? Like a digital psychic who's exactly you. You totally nail decisions. Like knowing squats might tweak your knees because your twins got the scoop. Sure, you're not quite living in sci-fi movie with full-on avatars yet, but digital twins are already out there, rocking the real world in amazing ways by simulating everything from workouts to machines. In this video, you will explore the foundation of digital twin technology through a familiar tool in your health tracker, like a Fitbit. You'll discover what a digital twin truly is, how it operates, and the core principles that define it. You'll trace the origins of this groundbreaking concept back to its root in 1960s, uncovering how it evolved into the tech-shaping industries today. You will dive into the distinct type of digital twins, what they are, how they differ, and the unique roles each one plays. You will compare how digital twin software works across both scale application and massive systems. Finally, you'll demystify the key differences between traditional simulations and modern digital twins because, yes, they're not the same thing. Let's zoom into the foundation of digital twins. Starting with something familiar, like Fitbit's Apple Watches worn by thousands. These tiny powerhouses scoop up everything, your activity, your sleep, your whole vibe inside. They're loaded with this sleek math and science model. Some are data trained to catch whether you're walking or crash out, while others are physics to track your heartbeats or sleep vibes. Blend that data with models and boom, data assimilation kicks in. It's like your custom digital twin taking shape, constantly updating as your body spills more data and payoff. You unlock recommendations and tips that are all just about you. So what's a digital twin? Picture a virtual version of something real, like a digital mirror that's loaded with data tracks and the physical parameters live. It's your go for simulation, integration, testing, monitoring, controlling, maintenance, and analysis how it's made. You grab every detail about whatever you're copying, every part, how they click together, even the space they're in, and rebuild it digitally. Cool, right? Digital twin works in 3 key stages: see, think, and do, which you will understand each one. First, you take your real-world object or process and load it up with sensors and IoT devices. These gadgets are like spies keeping tabs on all the vital stuff. They're constantly grabbing data about how the object's performing in the real world. Then, the collected data will mix with the models, usually based on physics, to build something special, a digital twin. This isn't just a virtual copy. It's a personalized, one-of-a-kind model tailored to your specific object. And here's the kicker, it's not static. The digital twin keeps evolving, thanks to a steady flow of fresh sensor data plus user feedback, new inputs, and even historical data to make it sharper. That's the C stage. Now that you've got your digital twin, it's time to put it work. In the think stage, the twin taps into some seriously cool tech. Think artificial intelligence, AI machine learning, ML simulations, data science, and control systems. With all this brain power, it can play out what-if scenarios such as what if you tweak the design, what if time passes or conditions change. The best part, you can test all these ideas without ever touching the real-world object. It's like a sandbox where your digital twin experiments with changes, showing you the effects on performance or safety, while the actual asset stays safe and sound. Finally, in the do stage, all those brilliant insights are taken from the simulations and brought back to reality. The digital twin doesn't just dream up ideas, it proposes actionable options. Whatever it is, the real thing gets better. Now you can break the digital twin concept, which is built on 3 parts. First up is the physical object or process, simply doing its thing in the real world. Next is the digital twin, which is like virtual clone, tracking every move. The last part is the digital thread, this excellent link that keeps them talking, passing data back and forth like live stream. It's the ultimate tag team between the physical and virtual world. It turns out that the digital twin was kicked off in the 1960s with NASA. They were using mirroring tech to make copies of their space systems. The big test came from Apollo 13 when oxygen tanks failed, leaving the spacecraft stranded. NASA didn't freak out. Though they had a replica on Earth, they grabbed data from the actual spacecraft, fed into their ground simulator, and tweaked it to match the damaged ship. From there, they ran all sorts of what-if scenarios and played around with prediction to pick the winning moves and bring the astronauts back home safe and sound. Total game changer. Digital twins aren't one size fits all. They've got layers where they shine depends on what you're focusing on. Here's the lineup. First, the part twin, a digital snapshot of one little component like a servo motor or a sensor that's critical to the whole deal. Next up is asset twin, when parts body up to make an asset. This twin tracks how they play together, spitting out performance data you can turn into gold star fixes. Next, you hit system twin, zooming out to show how assets link up into a full system. Total visibility on how it all connects. Fourth is the process twin. This one's macro, showing how systems sync to run a whole production gig, nailing down timing for maximum efficiency. And finally, the enterprise twin, a mega network of twin tied together in IoT to make the entire operation sleeker and smarter. Do you know where the digital twin software hangs out? The answer is for small and straightforward processes. The software is right on your desktop PC. The twin sends it to zeros and ones straight to your computer with no detours, super easy. But for the big and complex stuff, like a whole factory setup, the software jumps to the cloud. Here's the deal. The twin fires off its data to reach edge controllers. First, those little helpers near the action, and then the edge controllers relay data to the cloud for heavy duty crunching. It's all about the scale desktop for the small fries, cloud for the beast. Time to settle the score. Digital twin versus simulation. Both virtual but also different. Simulations like to keep it tight, zooming in on one process at a time. Like a solo act, digital twins go big, spinning up multiple simulations to explore a bunch of processes. All at once data is where it gets spicy. Simulations lean on all these cool statics inputs or whatever you toss in, staying chill without live updates. Digital twin grab real-time goodies from sensors, keeping everything fresh and lively. Info flow is one of the trip with simulations. No chit-chat, back to the source. Digital twins, though are chatty, swapping data with the object, both ways of real team vibe. Computing power simulations stick to a simple stage, modeling one thing at a time, while digital twins dance in fancy virtual playground with muscles. For more significant boulder analysis, and for boosting stuff, simulations offer a small window to tweak, but digital twins throw open the doors, giving you tons of angles to amp up products and processes. So simulations are cool, but digital twins are next level.